Elements of the normal distribution. The standard deviation. In order that you understand the normal distribution, it's important that you have a good feeling for the standard deviation as a measure of spread. This video will hopefully help you do so. Symbols. For the purposes of this video, we'll use the following symbols, which are located to the left. Mu is the mean. Sigma, the standard deviation. Xi is a set of all the raw scores found in the distribution. Capital N is the population size, essentially the number of raw scores. Something to remember. The standard deviation can be calculated for any distribution, but it is most useful for distributions that are normal, i.e. symmetric and in a bell shape. And here I've drawn one kind of a standard normal distribution that is symmetric, i.e. this area 2 and area 1 are equal. If the distribution is skewed, and I'll just quickly remind you of those skewed, i.e. something like that, J-shaped, like that, bimodal, or other strange kind of distribution shape, then the standard deviation and mean are actually quite weak in their ability to describe the center of the distribution. Let's look at a comparison of two distributions using only the standard deviation, meaning that the standard deviation will be different. Everything else will be the same. To the left we have population A. Population A has a mean of 12, sigma 2.3, and n equals 11. And these are the 11 points here. Let's plot them. We have 3 12s, 1, 2, 3, so I'm plotting these on a dot plot. We have 1 11, so I do it about 1/12 of the way between 0 and 12. We have a 10, fairly close here, and a 9, and an 8. Okay, probably a little bit too far to the left, but that's okay. We're just estimating. Then we have 2 14s and 2 15s. So that gives us the distribution for the population A. So take a look at how it's spread out. And we know the center is 12. Next, population B also has center 12, mean of 12, and has sigma 5.3, so quite a bit larger, and with 11 points as well. We start with the center, 12, so we have 2 points there. We work to the left at 9, so it's a little bit of a drop, and then we have close by 8, 7, 6, and 5. To the right, we have a jump to 15, and then we have 17, 20, and 21. So you can take a look at these distributions and you can see quite clearly that the one to the right has a larger standard deviation and is more spread out. Let's look a little bit closer. To the left, we have standard deviation 2.3. Let's take a look. From 12, this is 14, so 2.3, that's going to be sigma equals 1. Sigma equals 2 is going to be another 4, that's going to be about 16. And sigma equals 3, it's going to be way past the maximum of the distribution. Same thing going down, 12 down to 10. This was 11, right? 10. So this is the point 10, so we go about here. That's sigma equals negative 1. Sigma equals negative 2. And sigma equals negative 3. So that's going to be at about 6. Now let's look at the distribution for population B. Distribution for population B has a standard deviation of 5.3. And the next point up from 12 is 15, then we have 17. So this point here, x9 equals 17. And we know that's roughly sigma equals 1. From there we go to 22 point something, that's sigma equals 2, and sigma equals 3 is off the chart somewhere here. Same thing on the way down. From 12, this point here is 7, x3 equals 7. 12 minus 5, that gets us to 1 standard deviation below. From there we go to 2, sigma equals negative 2, and then sigma equals negative 3 here. So notice these points have both a value of the standard deviation and have x values. Let's extend that notion to larger populations. So here we have populations of size 11. Easy to plot all the dots, all the individual raw scores. Here, it's a little more complicated. We have population A1. Same thing, mean is mu is 12, sigma is 2.3. How would we plot distribution for 11,000 points? Well, similarly, we start with the center. What we know is that it'll be a bell curve with the center at 12. So that's roughly a certain number of dots. And we can continue now. We also know sigma equals 2.3. And going back to the first page, so this is one of the things about the normal distribution that we're learning about, is that most of the data, right, this goes on here and here, but most of the data is within 3 standard deviations from the mean. So we have 3 standard deviations, then we kind of run out of steam. So here we'll end up 3 standard deviations away. 3 times 2.3, that gives me 6, plus 0.9, roughly 7. So that gets me to about 19, which is here. So that's going to be 3 standard deviations away. And I'm going to drop a curve here. Let's zoom in to make it a little easier for me. And then inside here I just put a series of dots that are going to represent 11,000 individual raw scores. Each of these is a separate xi. And the same thing this way, 6.9, so that's roughly 7. If I drop it down here, that's going to take me to about 5. So that's going to be about here. And the same thing I drop, and we get roughly a normal distribution with points, a bunch of xi's, raw scores. And this is sigma equals 3. Sorry about the equal signs there. That'll be sigma equals 2 and sigma equals 1, which corresponds to x equals 14.3, x equals 16.6, x equals 18.9. The same thing to the left. I'll zoom in again. That's going to be roughly sigma equals negative 3, sigma equals negative 2, sigma equals negative 1. And you can calculate those for yourself. What do we do when the standard deviation is just a little bit higher? Well, one thing we'll know, okay, if you look at a comparison, one thing I know, this will be more spread out. How much more spread out? Well, we're going to go 3 standard deviations from 12. So we're going to go way over to the 27 here. That's going to be the predicted standard deviation. But I still need to get a 3 standard deviation. This way gets me into negative territory here. And what you see is I don't go as high as I did the 12. The number of individuals at 12 will be lower because I still need to get 11,000 dots under the curve, under the whole curve. So there's still 11,000 of these dots going all the way across. And in the same way as I drew before, 17, 22, and sigma. Hopefully, this video has given you a better understanding of the standard deviation.